Has anybody ever tried to rate a tornado?
And I would like to know why you can never get to the end of a rainbow.
What's the worst disaster in Iowa?
What are your top 3 movies that involve weather?
Welcome to Weathered Questions, where we answer the questions on your radar.
Welcome in, everyone. Thank you very much again for listening to Weathered Questions, the podcast that's all about weather, where we answer the meteorology questions on your radar. And you can submit your questions, as always, to weatheredquestions@gmail.com. Meteorologist Kai O'Mara with you, alongside meteorologist Jan Ryherd, plowing right along in April. Jan, how's it going on your end?
Things are going really well, really busy, but starting to get some warmer days that we can enjoy out on the bike and frolfing and all the good outdoor stuff, as long as it's not too windy.
Right. And a fun fact, even though nobody asked about it, but we'll go ahead and interject because we can. April's the windiest month in the Midwest on average. So for our Midwest listeners, have some fun. Go fly a kite. It gets the kids out of the tablets. That's for sure. We are going to be talking about this week's Cloud of the Week. Last week, we had a debate about how to pronounce the cloud. This week, there's no debate on how to pronounce it. But
just tongue twister.
You have to reload your mouth a couple different times. So here it comes. I'm going to feed it right to you, and then you can take it from there, Jan. So our Cloud of the Week is Kelvin-Helmholtz waves. Take it away.
Ooh, you did it. I'm glad you said it, so I don't have to, because the easier way to say it is KH wave, because stands for it, abbreviate it, right?
That's what you put in the rundown. You cheated. You made me have to do it.
Spell Kelvin-Helmholtz. I do, but it is a little tricky. So these clouds are named after some people, Kelvin and Helmholtz, because that's what we do in science. We name things after ourselves. So these are wave clouds. A lot of people actually will formally call them wave clouds, but their actual name is KH waves or KH clouds, Kelvin-Helmholtz. So what these are, you have maybe seen them. I would say they're even more rare than the couple of clouds we've talked about here recently that we've said they're pretty rare. I would say they do not happen that often. At least I do not observe them very often. They're kind of a mid-level cloud. And a lot of times you'll see kind of this band of clouds, maybe off in the distance along just above the horizon or something. And you'll see these little peaks. And they look just like little Dairy Queen curly cues that come across the top of the clouds. And so they just look like little waves, just a bank of clouds that has little whips and little curly cues coming off the top. That's the best way to picture it, I think, in my head. I'm kind of drawing them with my fingers as I'm going, which is really great for audio, I know. But
I'm seeing you do it.
Yeah, Kai can vouch for me. But that's what they are. And what's happening is you've got slower moving air at the base of those clouds and air that's moving faster at the top of those clouds. And it's essentially blowing the top of that cloud, just kind of blowing it off and kind of overturning it. So the way that I like to envision this with my when I do school visits with kiddos, if you have a pen or a pencil or a battery, a chapstick, something round nearby that you can hold, put that in your hands. Your bottom hand that is holding that is going to be your slower moving wind. Roll your top hand faster than your bottom hand over that, and you'll see that rolling start to happen with whatever round thing it is that you're holding. And so that kind of shows you that motion that starts to roll the top of the cloud over onto itself and starts to kind of create that wave-looking shape. So that's cool. That's what's going on with the Kelvin-Helmholtz clouds.
I never thought about that experiment. That's
also
cool
how I describe
visual.
Tornadoes.
Yeah. Well, I mean, that's, if you think about it, so if you're a pilot and you ever come across a situation that looks like this, that's essentially, you are seeing wind shear in action is what you're seeing. And that's not so much directional wind shear. That is what we call speed wind shear, where the wind is blowing the same direction. It's just all of a sudden you go up a couple 100 feet and it's a totally different boom. Like it's hauling up there. And all of a sudden you see it just like a wave breaking in the ocean. So we rarely see them in this part of the country. But other areas that see them, it's a great indicator of, again, extreme turbulence if you're an aviator. So great to avoid those if you're in an airplane, but it certainly makes for a neat visual when you're on the ground. And you can sometimes see those, and the wind on the ground isn't doing nothing. It's totally calm on the ground, but yet you can see them in the distance. It's very cool.
Also, I mentioned they were named after people. Formal names: Lord Kelvin and Hermann von Helmholtz are their names. If you could get any more of a mouthful than Kelvin-Helmholtz.
Yeah. They sound very official. Yes.
So yeah, they're a pretty fun cloud to see. If you haven't already, I encourage you to Google it and check them out, because they are pretty cool. And if you don't know how to spell it, just type in KH clouds or KH waves and they will come up. But only after you're done driving. If you're listening while driving, please don't Google and drive.
Good point. Good point.
All right, Kai, we've had this question in the bank for a little while, but we haven't gotten to it because we needed to do some research. So we've had time. We've done our research. The question is, what is the biggest one-day temperature swing? Go.
Good question. So cold fronts and warm fronts are extraordinarily commonplace in the United States. If you know anybody next to Lake Michigan, you've seen the weather change drastically in the mid-afternoon. The lake breeze comes in. If you're in the northern parts of Michigan, you've seen that as well. Mountain ranges, things can get really warm very quickly. Things can drop really quickly. So this record is held in Montana, of all states. Maybe it's a state that you thought would have the record. Probably not. You probably thought it was a different state. But
We're pretty sure this is a world record too.
Correct.
Not 100%, but we're pretty confident in that. So
we're pretty confident. So the source on this is the folks at Guinness World Records. And we've got two different things to bring to you. First one is the greatest temperature variation in a single location, just over 24 hours. And this was a rapid temperature rise. And it was due to what we call downsloping Chinook winds. And I'll explain the science in a second. The big word episode, Jan. We're just getting started.
Kelvin-Helmholtz,
7 minutes in. They were at 54 degrees below zero for their morning low.
Oof.
They, 24 hours later, had gotten up to 49 degrees above zero. So that's a rise of a massive amount, 103 degrees. And you may be wondering how it's even possible. So one great experiment, speaking of experiments, because this time of year, your kids might be wanting to go out and ride bikes, get everything out there, get going, get the basketballs pumped up. If you go out there with a bike pump and you bike and you pump those tires up and you do it quickly, what's going to happen when you pull that attachment off is the chassis of your pump is going to be really hot. Mm-hmm. Sometimes it's pretty hot to the touch, actually. And all you were doing was compressing air. That's it. That's all you did was compress air. So as air rushes down what we call the lee side of the mountain, then it starts to warm and compress. And it does so at a rate of about 10 degrees Celsius per kilometer, or about 5.5 degrees Fahrenheit per 1,000 feet. So you could see if we have a cold air mass at the top of the mountain that's starting to get going and really start compressing and warming, they used to call those, and I think they still do in some parts of the area, the dry Chinook winds are nicknamed snow eaters. You can see those things melt 1 foot of snow in a day because of how warm it gets so quickly in the afternoon. Now, this I wouldn't call 49 necessarily warm, but compared to 54 below, it definitely is.
Yeah.
But then there's also the reverse. It can get cold there too, as we know. And so this was back in 1916 when this one happened. This was the greatest temperature fall, which was also in Montana. So the greatest temperature range in general was Loma, Montana. This one was in Browning, Montana. And it dropped 100 degrees from 44 degrees Fahrenheit for the high down to minus 56.
Wow.
This was January 23rd and 24th of 1916. So the greatest spread was actually, I don't want to say it's recent, but 1972.
Yeah.
I was born in 84. That's not that
no.
crazy. It's not that crazy to think about. But then
It
you
really
think about
isn't.
then you think about temperature variations and what we've seen around St. Patrick's Day.
I was just thinking about that.
Yeah, so
There was
I
like a
actually
50 degree, 50 to 55 or so, at least here in Iowa. But again,
and that's just 24 hours.
yes.
If you spread it out over 5 days, it was a 90-degree
Oh,
swing.
yeah.
So granted, it's not, within that day window that they had in Montana, but that's the climate you would expect some of those big bounces in temperatures to be. So for those wondering, it's about 100-degree spread in a 24-hour time frame in one city. And both the rise and the fall happened out in Montana. And the first one is clearly downslope compressing air, strong winds.
Hmm.
The second one is probably just a ridiculous Arctic front. Probably. I don't
Highly
have a
likely.
surface map from 1916, but I'm just going to use
we'd
the
have
old
to go
noggin
back.
and say if we were in the 40s and now we're in the minus 50s, Jan, I bet a cold front hit.
Yep.
It's probably a big one too.
Good deduction there, Kai.
Yes. There you go.
Well, I think that leads nicely into another question that we were asked, and it is, what is the hardest weather to predict? Talking about those huge temperature swings, anytime you have something like that, that is going to be complicated, right? And so, Kai, you kind of noted how both of those happened in Montana, talked about the mountain setup and Chinook winds and stuff like that. And we can dive into that a little bit more still. I think that mountain component is very important to this. But just kind of talking about like the big temperature differences are going to be in those drier climates, right? There's no ocean near Montana. It's typically pretty dry. There's not a lot of humidity, especially in January when these things are happening. And so that's something that will lead to those bigger temperature swings, is that lack of moisture, and the landlocked nature of a place like Montana. But diving into difficult to predict weather, also again very very Montana-esque, is mountains. There's so much topography impact from the rising air, the sinking air, the fact of how rain is formed as it's kind of colliding with those mountains, and then you have the rain shadow on the backside there. So there's so many different factors that are going into that, and forcing of air upward and then downward again so quickly, that make mountains really hard and hard to predict. Mountains are rocks; they're also very hard. But the other thing that I think about here, on a smaller scale, is we as meteorologists, we rely a lot on radar. You've probably heard of the radar, right? That's how we look at precipitation a lot. And radar and mountains do not get along, because the way that a radar works is that it sends out a beam and it waits for that beam to come back. However, mountains are very jagged, and if you put that radar on the very top of the mountain, you are sampling so high up in the atmosphere that the people at the bottom of the mountain aren't getting any usable data, because that radar beam is so far up in the storm. If you put it on the bottom of the mountain where the people are, then the radar beam just immediately hits the mountain. So
Right.
both of those things, we just don't get good data around mountains. And you can actually see this if you look at a radar map, a coverage map of the country. You'll see all these kind of cutouts around the mountains, because we just can't get good radar data there without having a whole bunch of radars, which is just not economically possible.
Yeah, we've dealt with some stuff too where sometimes the snow doesn't show up very well in Colorado, especially because the radar beam's a little bit too high. So that's one thing worth monitoring, as you correctly said there. But the thing about radars too is that the beam spreads out also as it goes away from the radar. So even if the center isn't hitting part of a mountain, the beam base might be grazing it. And so sometimes you get these returns that show up. And like if you put an animation on a radar loop and it's the very lowest tilt of radar, if you see a bunch of targets that are never moving, chances are it's, in the Midwest, it's probably a wind farm that you're hitting. But if it's in the Mountain West, it's probably elevation. It's probably some sort of elevation topographic feature, likely a mountain range, but not always. I mean, it could be just an elevated area. Might not be a mountain per se, but that is a big challenge. And then that part of the country. So this is one of the things that regulates temperatures around marine areas is moisture. That's why Miami, Florida has a very predictable climate. It really is very predictable. Even if you go down there and celebrate Christmas, 10 years from now, I can probably get within 10 degrees of what your high is going to be. Probably. Yeah. Just because there's so much water to regulate it. It's kind of like a stabilizer. Then you get tossed into the mountains. Oh, by the way, the dew point 0, air is extremely dry. The sun warms it up very quickly. And I can't tell you how many times I've had, friends and relatives out west say it is darn hot out here. Yep. And I experienced once a sand volleyball game in Fort Collins, Colorado, and it about burned my feet. But that night we were in the 30s. Yeah. It was just amazing to me how cool we got, because when we've got the 90s in July, we can't get hardly below 60 because of the corn crop and the dew points the way they are. But out west, you don't see cornfields, and you don't have a Gulf of Mexico or America, whatever you want to call it, flow coming up into the Rockies. It just doesn't happen. And so that's an extreme place for weather. It's very challenging to predict out there, for sure.
It really is. Yeah. It is not for the faint of heart.
No. The Canadian prairies also can give, even an elite forecaster a run for their money. Not necessarily a whole lot because of elevation, though you do get into mountain ranges, obviously, but they don't tend to get a ton of moisture up there. But when they do, there is a small hail alley up there too. That can be from Alberta to Saskatchewan to southern Canada, and it lights up. And the Canadian radars can detect that just as well as the American radars can. So Canada can be kind of a challenging spot too, just because of some of their extremes. But again, the common denominator here is the farther away you are from water and add some elevation into the mix, probably the harder it is to predict.
So that's a good rule. We talked a lot about like hardest place to predict. I do want to touch a little bit on for this question, like the type of weather, just in case anybody is curious about that. As a Midwest forecaster, I would say yes, all of it. But yeah, my answer is always snow, and only because of amounts. I think predicting snowstorm occurrence is a fairly good science that we've got it down to. But I think that we all get hung up on totals so much. And if you think about it, that 1 inch of rain in the summer is an inch of rain, and it soaks into the ground and it's gone in a heartbeat, and it doesn't matter. Okay. That is said loosely. Rain matters. We all need rain. We understand.
I get what you're saying.
It's not piling up in your driveway.
Right.
I
got you.
Don't at me. But in the winter, if you have that same 1 inch of liquid water in the air suspended, depending on the temperature at the ground, it could be closer to an inch. Because there's a high liquid content, or it could be closer to a foot because you have such dry, arid conditions. So that is personally my least favorite type of weather to predict. And again, solely because of snow totals, not necessarily the will it snow or won't it snow. And there is a little bit of a component to that too, because we can get some kind of stratus flurries out of nowhere that are just really a pain in the butt.
Oh yeah. Oh yeah. I lean into that with you. Yes. I think that would be very difficult in elevation. And then that just goes hand in hand with, if that's a challenge, that means temperature is also a challenge. I mean, that's just really hard. 1,000 feet can mean a huge difference between a terrible day and one that's actually quite nice. So yeah, I think that all definitely goes hand in hand there when we're talking about that particular spot. So now, if we're talking about hardest weather and extreme weather, and severe weather especially, there are different severe weather risks that are issued. And we see them on television, we see them on social media. The question is, how are the severe weather risk categories determined?
Yeah, so great question. And we could go into a few different facets with this. The simplest answer is there are some lovely folks at the National Oceanic and Atmospheric Administration, NOAA, in a little sector called the SPC, or the Storm Prediction Center. And they are exactly responsible for that, storm prediction. And so they are the ones who are on a regular basis responsible for uh, figuring out really the entire country, who is at the most likelihood of having severe weather, and they forecast up to 8 days out for their more detailed maps. So they are the ones who are kind of calling the shots in that. Now, that said, they are in conversation regularly with local National Weather Service offices, and especially once they, on that kind of day 8 time frame, have started pinpointing areas, that they are in even more regular conversation. But ultimately, it comes down to what the SPC is saying for, again, who's going to be in that risk category. So it's not, you know, uh, channel 1 says this and channel 2 says this and channel 3 says this. Everybody is using the same severe weather risk categories and map. Maybe they call them a little different, maybe they color them different, but it's the same contouring, and all of that that's going into it. Not to say that, again, most TV stations have degreed meteorologists that are working there, and so not to say that people can't come up with other ways to show that information. But in general, it is going to be your storm prediction center that is determining where the severe weather is happening.
Yep.
Kai,
At least
I
where
will
it's
let
going to be
you dive
forecast.
into, yeah, I'll let you dive into a little bit of maybe the how they're pinning down those spots of what they're looking at. Um,
Well, that's a good
so,
question.
yeah.
It could be upper level features like jet stream. It could be mid level features such as either pockets of cold air or pockets of wind maximum that are flying around. And then the low levels, we're looking at dew points. We're looking at surface temperatures and instability, how the winds are changing as we go up in the atmosphere. But the biggest take home message for everybody listening is that there's generally about 5 different categories that you hear about. And through the Storm Prediction Center, they have official labels for them. I have now seen that nearly all television stations, and it looks like most of the National Weather Service is using, a scale out of 5, like a 1
Hmm.
out of 5, a 2 out of 5. And so the 1 out of 5 is considered a marginal risk, which is limited storms in duration or coverage or intensity. So not usually a big deal. Slight risk, or a category 2 risk, essentially means short-lived, not widespread, but isolated intense storms are possible. Okay, so it's a possible kind of day. Level 3 is an enhanced risk, where numerous severe storms are possible, more persistent, a little more widespread, a few more intense ones. And then you get to your category 4s and 5s. And in category 4, a moderate risk indicates widespread severe storms likely, long-lived, widespread, intense. And then the category 5, which is generally a 1 or 2 times per year in the country risk, not a local area, but a 1 or 2 times per year in the country. Widespread severe storms expected, not likely, but expected. Those are very 2 different words there. Long-lived, very widespread, particularly intense. And they issue those for essentially tornado outbreaks is what they usually are reserved for. You could have a high-end derecho situation if it is foreseen. A lot of times derechos are not foreseen to a high-risk level. I know the August 10th, 2020, I believe, capped at a moderate risk. And that is the strongest derecho in North American history. So, in an ideal world, you'd want to see a high risk on that. But the way that derechos operate, you don't tend to get that kind of lead time. So that's a little bit about how those categories work. And the common sense logic says, if you're 1 out of 5, probably not a big deal. If you're 3 or 4 out of 5, really pay attention. 5 out of 5, exceptionally pay attention.
Yeah.
At that point.
And there is technically like a level 0, I guess you could say, level
Yes.
half.
Just a
That
general
is just
thunderstorm.
general thunderstorms. Yeah.
Yes.
Which here in the Midwest, at least, again, this will change depending on what weather you're used to, and what is normal for your area. But I would say that people unfortunately ignore the lower categories, and it's not really until you get to that enhanced risk that people take notice. Just because we do get a lot of that slight is you do get thunderstorms out of it. That's when you do get strong winds and hail potential, but it's usually so isolated that we've kind of almost programmed ourselves to ignore it, which is kind of a bummer, and does bite us in the butt sometimes, as the public. But again, depending on where you are, those categories may mean a little bit different things, just based on how much you're normally getting thunderstorms, right? But it's the same categories for everybody.
Yep. I'd say if you're in a level 2, a slight risk, just think that scattered storms are possible that could be strong to severe, and kind of leave it at that mentally. Don't let the slight get you too far out of your comfort zone.
Exactly.
It's more to be messaged that there's just probably a few storms that could be a little intense. So just be advised of that if a slight risk or a level 2 ever gets issued in your area, which if you're listening in the Midwest, it's just a matter of time before it happens again.
Yep, absolutely. Well, thank you everybody for spending some time with us yet again to talk severe storms and temperature swings and everything else that's fun and crazy in the weather world. If you have any questions that were sparked by today's conversation or that have been lingering in your mind for a little while, be sure to shoot us an email, weatheredquestions@gmail.com. Join in on the conversation. Let us know what is on your radar. And until next week, stay safe.